So, dear students, as I was telling, let us start discussion on irrational inequalities, and you will find it very interesting as we proceed. So, before starting, I just would like to confirm that all of you are able to hear my voice very clearly, and also you are able to view the digital board.
Yes, sir.
All right. So, the way I always, you know, start a discussion is that with an example, and example makes things to understand that how to go back to the theory and what are the different perspective of the theory. So, let us look into this particular equation. Square root of x plus 14 is less than x plus 2. Now, while solving this inequation, we need to follow a guideline. And that guideline first you learn, and then once you understand, yes, that guideline makes sense, then you will find it is so easy to solve this kind of inequalities. Generally, what happened, dear students, is that without having this guideline, whatever the existing knowledge you have, based on that, if you start applying the start solving, generally what you do, we just make a square of both the sides. Now, before making a square, you need to understand about very important principle. If two numbers are such that a is less than b, can you always guarantee that a square is less than b square? Not always. Okay, that is very important to understand. I'm coming from a very common thing what students generally do. If you see that generally what is our practice is that if a is less than b, we generally write a square is less than b square. No, it is not. Okay, let me give an example. Minus 5 is less than minus 3.
The square is great.
But square is greater. That doesn't imply that minus 5 whole square is actually not less than equal to minus 3 whole square. Correct, no? But one thing you know that 5 is less than 7. That always implies that 5 square is less than 7 square. So what we are saying in general, when we say that a is less than b, that may imply a square is less than b square, or that may imply a square is greater than b square, depending on what is the sign of that a and b. What values they are positive values or negative values. And dear students, while discussing these irrational inequalities, these concepts comes in a very, very important, very, very important. So let us first understand what is the underlying theory, how to solve this kind of inequations. Okay, because these are the corner cases you need to follow. The guidelines goes like something like this, that the first guideline I'm mentioning because the question what I gave, dear students, is relevant to that guideline. And similarly, I'll proceed with others. Okay. So the guideline, it says something like this. Able to view, dear students, all of you able to view?
Yes, sir.
Okay. So it says that while solving irrational inequalities, we should follow the guidelines as mentioned below. An equation of the form, that is 2nth root of fx is less than gx, for n belongs to capital N, that is a set of natural numbers, is actually equivalent to the following system of inequations. If you see, dear students, fx greater than equal to 0, that is one system of inequation, one first inequation. Then gx is greater than 0, that is second inequation. And the third one is fx is less than gx power 2n. That is another equation. So that means solution to these three inequations combinedly represent the solution to the given inequation that 2nth root of fx is less than gx. Correct? And you know, it is very generic, 2nth root. The point is that how we can apply this concept here in the example. Let me use a different color. So if you see the example, the question what we took now, solve the inequation square root of x plus 14 is less than x plus 2, actually fall into this category, because square root means it is a 2th root, correct? No? Second root, correct? So then what we can write from here, dear students, if you look into it, so from here we can write that definitely that x plus 14 has to be greater than equal to 0. Here what is fx? Fx is x plus 14, na? If you make an analogy. So fx is x plus 14, correct? So what we understood from this guideline, x plus 14 has to be greater than equal to 0. And then the second one is that x plus 2 has to be greater than 0. Correct or not? And third one is that fx, that is x plus 14, has to be less than x plus 2 whole square. I hope all of you got it.
Yes.
And you know, dear students, what I did in the the last step, x plus 14 is less than x plus 2 whole square. It is just like that. It is something like that. A less than b, I wrote a square is less than b square. Why? Because both a and b are positive. That is actually being confirmed by these two.
Yes.
That's what we have done now. 5 less than 7. That means what? 5 square less than 7 square, as an example. When? Because both 5 and 7 are greater than 0. But this was not the case when minus 5 less than minus 3, correct? So what we'll end up with, dear students, that we'll end up with to solve these three system of inequations. And this is easier to solve, correct or not? This is easier to solve than, going with some kind of apprehension or confusion. There is no confusion because we have this guideline here. So from here, what we are going to get? Now, this implies what? This implies x is greater than equal to 14. Sorry, minus 14. X is greater than equal to minus 14.
Yeah.
Then second one is coming, x is greater than minus 2. Correct, no? And third one is that if you simplify that x plus 14, then less than x plus 2 whole square, if you simplify, you will get something like that, x square plus 3x minus 10 greater than 0. So all these three system of equations has to be satisfied. System of three inequations has to be satisfied. Correct, no? So then, if we simplify further, means if we go, if we simplify further from here, what we are going to get, dear students, this implies. So from here we get these three. So from here, what we are going to get is that x is greater than equal to 14. X is greater than equal to minus 14. X is greater than minus 2. And x square plus 3x minus 10, you can do a factorization. You will get x plus 5 into x minus 2 greater than 0. X plus 5 into x minus 2 is greater than 0. Correct or not?
Yes.
So if you recall, we discussed in one of our earlier classes that x minus alpha into x minus beta greater than 0. That means either x is greater than maximum of alpha and beta, or X is less than minimum of alpha and beta.
Yes.
So from here, what we can get is that we get x greater than equal to minus 14, x greater than minus 2. So between, so x minus 2 and x minus of minus 5. That implies either x is less than minus 5, correct or not?
Mm.
Or x is greater than 2.
Mm.
So now all these things you can put into the number line, correct or not?
Mm.
So if you put a number line, if you just put a number line, just a minute. If you put this thing in a number line, you don't need to be very precisely correct to enter all the numbers very correctly, but you need to be relatively in the numbers should be relatively positioned properly. So this goes to infinite, in the left hand it goes to minus infinite. Minus 14, suppose minus 14 is here. Suppose this number is minus 14, correct now, dear students? So one solution tells that x is greater than equal to minus 14. That means it should be filled up greater than equal to closed interval, correct or not?
Mm.
Let me use a different color, just a minute. So let me use a color of green, suppose. So x greater than equal to minus 14 is this solution, no, dear students? It goes to this. That represents the first one, x greater than equal to minus 14. Then where it will be minus 2? Minus 2 will be somewhere here, no, dear students? This will be minus 2, correct?
Mm.
So now next one is that x greater than minus 2. So it should be an open interval, unfilled circle, correct, my dear students? Correct? And the third one is that x is in between. X is either less than minus 5 or greater than 2. So where is minus 5? Minus 5 will be somewhere here.
Mm.
So less than minus 5 means what? Open interval. It goes like this. Correct, no, dear students?
Yes.
And greater than 2. Greater than 2 means what? Here it is 2. 2 will be here, na?
Mm.
So greater than 2 will be something like this. Open interval here. And it goes towards the right. The solution should be, dear students, you know, that where the common position I am getting, where is the common one? Common one, if you see very minutely, it is coming from 2 to infinite. This is the point 2. So if you look into from 2, open interval 2 to infinite, you will get everything. No? All these lines are getting crossed.
Yeah.
Correct? No? All these lines are getting crossed from a number greater than 2.
Mm.
We will not consider this solution. Why no, dear students? Because it is the OR statement. That is why the OR is a very meaningful word here. Our solution is either x less than minus 5 or x greater than 2 from the third one, what we are getting. No? But along with this, we need to satisfy these two also. That's why I say, no, the combined solution. Are you getting my point, dear students? So then what is our combined solution? Combined solution we are getting is that it is 2 to infinite, where 2 is in the open interval. So from here, what the solution we are getting, dear students? The solutions we are getting, x belongs to open interval 2 to infinite. All of you completely understood, dear students.
Yes.
Okay. Anyone has any smallest difficulty, please do let me know. So this is the way to solve that inequations of this type. So I just repeat once. Whenever you find an inequation of the form that fx to the power 1 by 2n, in one way we can say na, that 2nth root of fx is less than gx. That means what? It is fx power 1 by 2n is less than gx, like this form. Then it is as if that we are solving a three system of inequations. The first one is fx greater than equal to 0. Second one is the gx greater than 0. And third one is that fx is less than gx power 2n. Correct, na, dear students? Now, solving these three inequations, set of inequations, are simpler because there we can apply our previous knowledges as we have done here. If you see x plus 14 greater than equal to 0, very easy to solve. X plus 2 greater than 0 is very easy to solve. And x plus 4 less than x plus 2 whole square, that is x square plus 3x minus 10 greater than 0, that is also easy to solve. Why it is easy to solve? Because we have discussed earlier. If you recall, if you open the previous class notes or video lectures, whatever, you will find x minus alpha into x minus beta greater than 0 means either x is greater than maximum between alpha and beta, or x is less than minimum between alpha and beta. And that's what we have done. X minus 2 into x plus 5. That means what? X minus 2 into x minus of minus 5. So between 2 and minus 5, which one is more? 2. So either x is greater than 2. That's how you wrote it here. Or between 2 and minus 5, which one is smaller? Minus 5. So or x less than minus 5. So now after that we'll take that solution which is satisfied by all. That's the right way of doing is a number line. Graph also you can say in one way. Draw the graph and you see that where it is actually intersecting all. But one point you should say, why not considering this, sir? Because this is OR. There is OR statement. If AND statement is there, then we should have considered that one also. That is this one. If AND statement is there. Got my point?
Yes.
Okay. So like that, there are some guidelines. So all you need to follow is that guideline. You need to follow that guidelines properly. And again, let me repeat, dear students, these are not there in your in your board syllabus. These are actually applicable for JEE Mains and JEE Advanced. It is not there. It will never come for your board examination at the same time. Now, there is a second guideline. I'm just telling you the guidelines. After that, we'll solve few problems together. The second guideline says, dear students, is something like this. That if you find that fx power 1 by 2n plus 1, that means 2n plus 1th root of fx is less than g, then this inequation is equivalent to the following system of inequation, that is fx is less than gx power 2n plus 1. Correct, no, dear students? You're getting my point. So whenever you get this kind of form, as if it is a only single equation we are going to solve. That is fx is less than gx power 2n plus 1. That is the second form. So in these two forms, whatever you see, dear students, is that irrational. Obviously, you understand why it is irrational, because square root is there. Okay, not square root of every number is irrational. Square root of those numbers irrational which are you cannot find the roots. Na? Square root of 4 is a rational number. It is 2. But square root of 5 is not, because you really cannot 5. Na? Okay, square root which gives you an integer. Correct?
Yes.
So here we discussed about the 2nth root of fx less than gx and 2n plus 1th root of fx is less than gx. Now, there could be two different cases when we find that 2nth root of fx is greater than gx. Correct, not dear students? That should also be a case. That when we see that 2nth root of fx is greater than gx, then what guidelines shall we follow? So here we should follow the guidelines like this. I'm just going to mention it here, dear students. So if we see that 2nth root of fx is greater than gx, if we find that 2nth root of fx is greater than gx for n belongs to capital N, what we see? We need to, it is just like that, solving the following two system of inequations. The first one is that gx is greater than 0, gx is greater than equal to 0, and fx is greater than gx power 2n, and there is the and statement, gx is less than 0 and fx is greater than equal to 0. Okay. So when we see that 2nth root of fx is greater than gx, then we should follow this guideline. Then the fourth one is what is coming, dear students. I hope you understand that 2n plus 1 is root of fx is greater than gx, correct? No? 2n plus 1 is root of fx is greater than gx. Then what shall we follow? 2n plus 1 is root of fx is greater than gx, and then we should follow these guidelines. And the guideline here is that fx is greater than gx power 2n plus 1, as if that you are going to solve this inequation fx is greater than gx power 2n plus 1. So these are the four cases which we should follow while solving, irrational inequalities. While solving irrational inequalities, we should follow these guidelines. Because apart from these guidelines, nothing is going to come, na, dear students? Correct or not? These are the four things you can think of. So we will solve few problems. These are the guidelines. So first and foremost thing is that what you see, whatever they are inside this, both the functions are, has to be non-negative, fx and gx. Right? That is the first important point. If they are non-negative, then only you can make them, you can proceed further. That should be your first guideline, and very important guideline. As you see here, the example that we have done, that square root of x plus 14 is less than x plus 2. What we have done first? First we have done that x plus 14 has to be greater than equal to 0, non-negative. That is fx, and gx is x plus 2, that is greater than 0. And that should be followed with everything, for every question related to irrational inequations. Let us do the next question. Then you will understand why I am saying so. Correct, no, dear students? Let's proceed to the next question, and I hope you will enjoy it. So here, what we are going to solve the inequation is something like this. Let me make the question available to you another few seconds. I hope you got it, students.
Yes.
So solve the inequation. What is the inequation here? Square root of x minus 5 minus square root of 9 minus x is greater than 1. So the first and foremost guideline, dear student, can you please mute? And you can unmute. I think there is some echo of what I am hearing. Please, dear students, you mute yourself, and when you ask any question, unmute and ask. Yeah. Thank you. So the first and foremost thing is that as I just said, whatever they are inside the square root has to be greater than 0, na, dear students? Correct or not? So that means what? X minus 5, which is there inside the square root. Okay. We can reframe the inequation something like this. This implies square root of x minus 5 is greater than 1 plus square root of 9 minus 6. That we can do right now. And if you see, this is actually coming under the first guideline, where the second root of fx is greater than gx, correct? Huh? The first and foremost thing, dear students, is that x minus 5 has to be greater than equal to 0, na, dear students? So x minus 5 has to be greater than equal to 0. And 9 minus x has to be greater than equal to 0. This is very important. This is the first and foremost thing has to be followed. This is first and foremost thing has to be followed. Now, x minus 5, if we combine these two, what we are going to get? if we combine these two, you will get that x is belongs to the solution belongs to the closed interval 5 and 9, because x is greater than equal to 5 and less than equal to 9 at the same time. So that means 5 less than equal to x less than equal to 9. Correct or not? So this is our, this is under the under which we need to find our solution. Correct, not dear students? So what is the first? This is the maximum territory of the solution, you can say in that way. That whatever the value of x you are going to get by applying the other conditions, system of inequation, that should satisfy that it is in between 5 and 9. So it is not possible, means till whatever we have achieved, we can say that it is not possible to find a value of x which is less than 5, less than 5 and greater than 9. That we can say now. So now whatever the next condition we are going to apply and whatever the solution set we are going to get, that should be in between, that should actually abide by the guidelines. The value of x is in between 5 to 9. Now, let us concentrate on squaring both the sides, dear students. We can make the squares of both the sides, no? Up from here, whatever you see, let me use a different color. From this, what we can going to get? We can make square of both the sides. So what we will get? In the left hand side, we will get x minus 5 is greater than 1 plus 9 minus x plus 2 into square root of 9 minus x. Correct, not dear students? Why you are able to make a square? Because both are positive. Because x minus 5 is positive. So square root of x minus 5 definitely has to be positive. Again, square root of 9 minus x is also positive, because 9 minus x is positive. As both the sides of the inequations of these inequations are positive, we are able to square it and we can keep that same sign inequality. The greater than is greater than. So then, if we simplify, then what we are going to get? 2x minus 15. 2x minus 15 is greater than 2 into square root of 9 minus x. Correct, no, dear students? So now from here, two cases are possible. What are the two cases possible, dear students? One is that 2x minus 5 could be less than equal to 0. Correct? One could be 2x minus 15 is less than equal to 0. 2x minus 15 is less than equal to 0. If we make it less than equal to 0, then what we are going to get? And 2x minus 15 is greater than 0. These are the two branch we are getting out. Na? So now if 2x minus 15 is less than equal to 0, that means what? That implies x is less than equal to 15 by 2. X is less than equal to 15 by 2. Correct, na, dear students? Then what we are going to get? If 2x minus 15 is less than 0, that means when x is less than equal to 15 by 2, we see that 2x minus 15 is less than 0. That means that 2 into square root of 9 minus x is less than 0. Correct, no? Which is impossible. How it is possible? We only considered that square root of 9 minus x has to be positive. If square root of 9 minus x has to be is positive, then we can say 2 into square root of 9 minus x is also positive. And we see if x is less than equal to 15 by 2, 2 into square root of 9 minus x become negative, that is less than 0. So any value less than equal to 15x, any value of x less than equal to 15 by 2 is not an acceptable solution. And what is our global solution? Global solution is between 5 less than equal to x less than equal to 9. And 15 by 2, actually what we get is actually 7.5. So from here what we see is that any value of x, okay, any value of x belongs to, or we can say in terms of inequality, that 5 less than equal to x less than equal to 15 by 2 is not an acceptable solution. Correct, my dear students? You see the justification. So from here, what we are reduced to? From here, we are reduced our solution to, it should be 15 by 2 less than x less than equal to 9. Correct, my dear students? All of you got it, I hope. Now, let's proceed further. So what we have achieved so far is that whatever our solution is, that solution set has to be between 15 by 2 and 9, excluding 15 by 2 and including 9. That's why there is a 15 by 2 less than x and less than equal to 9. Now let's concentrate on 2x minus 15 is greater than 0, the right hand side. So from here what we see, dear students? We see x is greater than 15 by 2. Correct, no? When we see x is greater than 15 by 2, then 2x minus 5 is greater than 0 and 9 minus x, so obviously greater than 0, then we can square both the sides. So what we are going to get here, dear students? So from this inequation, 2x minus 15 greater than 2 into square root of 9 minus x, from here we can write 2x minus 15 whole square is greater than 4 into 9 minus x. Correct, na, dear students? And if you simplify further, what we are going to get? We are going to get, so we need to solve these inequations. So, we can simplify further. 2x minus 15 whole square, and you will find something like this. You get an inequation. So here what we are going to get? 4x square minus 60x plus 225 is greater than 36 minus 4x. So I am doing it purposefully because this is, not a very straightforward, equation which we can solve using factorization. So you are getting 4x square. Then we are getting minus 56 of x. And then we are going to get plus 189. Correct, na, dear students? Greater than 0. And you will find you will not able to factorize it, directly. So if you just recall, what are the solutions? What are the roots of this corresponding equation? If I use a different color, means if we consider this 4x square minus 56x, let me do it some corner so that you can, 4x square minus 56x plus 189 is equal to 0. Then what are the solutions we are going to get? X is equal to minus b, that is 56, plus minus square root of b square, that is minus 56 whole square, minus 4ac, minus 4 into 189, okay, divided by 2 into 4, that is 8, 2a. Correct, no? So what we are going to get, dear students, from here, x equal to, sorry, x equal to 56 plus minus square root of if we make 56 whole square, we are going to get 3136, correct na? 3136 minus 4 into 4 into 189, we get 3024. 3024 divided by 8. There is a reason why I'm doing all these things, because when we solve problem, you need to solve like this with complete patience, and also you need to be fast. So 3136 minus 3024, it coming 112. So 56 plus minus square root of 112 divided by 8. Correct, no, dear students? So from here, we can further simplify. X is equal to I can get 4 common from square root of 112, means 16 we can take common, so it will be something like 14 plus minus square root of 7 divided by 2. So what are the values of x we are getting? One value we are getting is that 14 plus square root of 7 by 2, and the other value we are getting 14 minus square root of 7 by 2. So that value we can apply here, and we'll get something like this, dear students. Let me come back to the same color. This implies that we get x minus 14 minus square root of 7 by 2. Correct or not, dear students? And x minus 14 plus square root of 7 by 2 is greater than 0. Now, if you remember, x minus alpha into x minus beta greater than 0, that tells what? That tells that either x is greater than maximum of alpha and beta. Here alpha and beta are respectively 14 plus square root of 7 by 2 and 14 minus square root of 7 by 2. Correct or not? So that implies, this implies either x is greater than 14 plus square root of 7 by 2, or x is less than 14 minus square root of 7 by 2. This OR statement is very important, dear students. So if you recall, what about the solutions we got so far? So far the solutions we got, okay, this was our partially accepted solution, because our entire solution should be within this. Now, if you find the value of 14 minus square root of 7 by 2, you can just approximate that value. If you find 14 minus square root of 7 divided by 2, you will get kind of 5.68. Okay, so that means it is less than 15 by 2 na. Got it, dear students? So what I'm saying is that either x is greater than 14 plus square root of 7 by 2. If we find that value also, 14 plus square root of 7 by 2 is approximately 8.32. It is 14 plus, okay, we can write it here, 14 plus square root of sorry, that is near to 8.32. One approximate value is fine. And if you find 14 minus square root of 7 by 2, it is approximately 5.68. Correct, no, dear students? Then what happened here? But if you see from these solutions, what we are going to get, 15 by 2 means what? 7.5. So 7.5 less than x less than equal to 9. So this one and these two, that we need to combine to get our final solution. If you see that here it is saying x is less than 5.68, but according to the question, according to the other solution here, x has to be greater than 7.5. So x less than 14 minus square root of 7 by 2 is not an acceptable solution. Got it, not dear students? So from this and this, what we are getting is that we see that as x has to be greater than 7.5, so x less than 5.68 is not an acceptable solution. So from here, what we see is that x has to be greater than 14 plus square root of 7 by 2 and x less than equal to 9. And that is the finally accepted solution. And we can give in terms of the interval, that implies x belongs to open interval 14 plus square root of 7 by 2 comma 9, that is closed interval. That is the solution to the given inequation. You see, dear students, apparently it looks like that, oh, there are so many, corner cases we need to include. Yes. But our tendency is to just make a square and proceed. No, not at all. It has to be abide by the guidelines what I discussed in the previous section in the theory. If I make a quick recap, what I can say is that square root of x minus 5 is greater than, we see that 1 plus square root of 9 minus x. Let me use a different color while I'll explain, just make a revision. So first and foremost, whatever is inside square root with variable has to be greater than 0. So here x minus 5 has to be greater than equal to 0. And 9 minus x has to be greater than equal to 0. So these are the very outer territory of our solution. That means x has to be between 5 and 9, including 5 and 9. So without proceeding further, you can say that it is impossible to find a value of x which is more than 9 or which is less than 5. Impossible. So that is why that is the first set of outer territory of the solution we got. Then as we found both the sides are positive of this inequation, then we make a square of both the sides and then we land up with this thing. Then we know that there are two cases possible, that 2x minus 15 could be greater than 0 or 2x minus 15 could be less than equal to 0. When you see that 2x minus 15 is less than, you see how I classify the problem, and very, very, very systematic approach. So first I found that x has to be in between 5 and 9. After that I'm coming that okay, 2x minus 15 less than equal to 0. Then we found that x has to be in between when x is less than equal to 15 by 2, then we see that 2 into square root of 9 minus x is negative. So that is not an acceptable solution.
Sir, could you explain how the two branches came, the 2x minus 15 less than?
Sure. Absolutely. Why not? Thanks for asking question, Mohor. So this part, I hope you understood, no?
Yes, sir.
Now from there, what you can conclude, if you go back to our theory that that 2x minus 15 can be less than equal to 0 or 2x minus 15 greater than 0. Possible, na? These are the two cases possible, right? If I say fx is fx, then you can say, oh sir, fx could be either less than equal to 0 or fx is greater than 0.
Okay.
So when 2x minus 15 is less than equal to 0, then what happened? Then we see that 2 into square root of 9 minus x has to be less than 0, na?
Yeah.
But that is impossible because 9 minus x is positive.
Yes.
How it is possible that 2 into square root of 9 minus x is less than 0? That is impossible, na?
Yes.
So that is why this solution is also not acceptable then. That's why I make it a cross sign here.
Okay.
So we see what? Any value less than equal to any value of x less than equal to 15 by 2 is not an acceptable solution. And we see that x could be between 5 and 9, including 5 and 9. So from there we actually, you know, restrict the solution from x less than 5 less than equal to x less than equal to 9 to, as you see here, I wrote now 15 by 2 less than x less than equal to 9.
Okay.
That is 7.5 less than x less than equal to 9. So initially it was big one, 5 to 9. From there we restrict to 7.5 to 9.
Okay.
So now, so what you can conclude so far, that any value which is less than 7.5 is not an acceptable. Correct? Now let's come to the other branch. So 2x minus 15 is less than equal to 0 is there, and second branch is that 2x minus 15 is greater than 0, which is this case. That means x is greater than 15 by 2. So x is, when x is greater than 15 by 2, so what we can do, we can make a square of both the sides, no, this one. That's what we have done it here, squaring both the sides.
Fine. Understood.
When you square the both the sides, after that you understood, now we exclude in the
Understood.
term of x minus alpha into x minus beta.
Yes, understood.
And from there we found that, okay, either x is greater than 14 plus square root of 7 by 2, or x is less than 14 minus square root of 7 by 2. Now, what is 14 minus square root of 7 by 2? There you need to find little bit of two decimal places, approximate value of this irrational number, 5.68. X is less than 5.68. That is not acceptable. Why? Because in our previous set of solution, we got x should be greater than 7.5. Correct, no? So when we combine these two set of solutions, these solutions and this solution, we conclude that x should be greater than 14 plus square root of 7 by 2, and x should be less than equal to 9. And that is the set theoric notation of this thing in terms of interval. That is an acceptable solution.
Yes, understood.
But what I'm saying is that by this, I just showed you that what will be the systematic approach. Correct, not dear students? And whenever you get this kind of inequations, dear students, always approach this, this systematic approach. I can, I can just give you a hints to the another one. Just I can tell you that how we can proceed. Okay. Let me go to the next question. Just I'm going to give you the idea. You can proceed after that and get back to me with your solution. For example, solve this inequation square root of 3x minus square root of 2x plus 1 greater than equal to 1. Correct? Now, if you go back to our fundamental concept that whatever is inside square root has to be, greater than equal to 0. Correct? Huh? So from here, what we can write? From here, we can write is that this implies, 3 square root of 3x, we just rearrange a little bit, is greater than equal to 1 plus square root of 2x plus 1, na, dear students. Then obviously from here, what we can conclude? That 3x has to be greater than equal to 0. Correct, na, dear students? And 2x plus 1 also has to be greater than equal to 0. This is quite obvious, na? Correct, na, dear students? Correct? And 3x should be greater than equal to 1 plus 2x plus 1. Correct? So these are the three things what you can conclude. So when these two are true, that 3x is greater than equal to 0 and 2x plus 1 is greater than equal to 0, correct, na? Then what we can say? We can make a square of both the sides of the inequations, na? Correct or not? So when we say 3x is greater than equal to 0, 2x plus 1 greater than equal to 0, and then from here what we get? X is greater than equal to 0. Correct or not? Clear or not clear?
Yes.
Now, after that, what we are going to do? So we get x is greater than equal to 0 and x is greater than equal to minus 1 by 2. Correct, huh? X is greater than equal to minus 1 by 2 is not an acceptable solution from here because x is greater than 0. Na? If you combine these two, what we are going to get? We are going to get is x is greater than equal to 0. Because from 2x plus 1 greater than equal to 0 means x is greater than equal to minus 1 by 2. So I am saying I have a number which is greater than equal to 0 and greater than equal to minus 1 by 2. You will say minus greater than equal to 0, na? Correct, not dear students? Because 0 is greater than minus 1 by 2. Correct? So we get from here x is greater than equal to 0. And then from here, as x is greater than equal to 0, then both sides of the inequalities are positive, you see. Square root of 3x is positive and square root of 2x plus is 1 is also positive. So definitely we will make a square. So square root of 3x is whole square is 3x. That should be greater than equal to 1 plus 2x plus 1 plus 2 into square root of 2x plus 1. Correct, dear students? So now from here what we can do? We can simplify further. If we simplify further, what we are going to get? 3x, here it is 2x, so x. So you will get it here, x by 2 minus 1. So it is, here it is, you will get square root of 2x plus 1 is less than equal to x by 2 minus 1. Correct? Now, from that given inequation, we'll end up with this inequation. Now here also what the conditions has to be followed. Here the conditions has to be followed is that x greater than equal to 0 already there. Let me use a different color pen. X greater than equal to 0 is already there and we are combining this. Then what we are going to get? We are going to get x has to be greater than equal to 0 and x by 2 minus 1, that should be also greater than equal to 0. Because 2x plus 1 greater than equal to 0, you no need to mention because x is greater than equal to 0 already mentioned. Na? And what we are going to get then? Again, we make a square of both the sides. We make a square of both the sides. Correct, not dear students? So if we make a square of both the sides, what we are going to get? 2x plus 1 is less than equal to x by 2 minus 1 whole square. Correct? Now you start solving this one. If you start solve this one, this will get a inequations, and from there you can find the solution. So what will be your solution set then? X is greater than equal to 0, x is greater than equal to half, and whatever the solutions we are going to get, we can do it quickly. So what we get? 2x plus 1 is less than equal to x square by 4 minus x, correct, not dear students? And plus 1. So from here what we are going to get? If you see from here, x square, so here we will get 3x, 2x minus x here. So we can multiply by 4. 1 got cancelled. So 1 got cancelled. So 3x is less than equal to x square by 4. Correct, not dear student? So from here what we are going to get? X square minus 12, x is greater than equal to 0. X square minus 12x is greater than equal to 0. This implies x into x minus 12 is greater than equal to 0. So if you recall the same thing, x means x minus 0 into x minus 12 is greater than equal to 0. Remember, x minus alpha into x minus beta greater than equal to 0. That means either x is greater than equal to 12 or x is less than equal to 0. Correct or not? That implies either x is less than equal to 0 or x is greater than equal to 12? But we already understood that x should be greater than equal to 0. So this x is less than equal to 0 is not an acceptable solution. So what we get, dear students? We get this implies x is greater than equal to 12. That is an acceptable solution. No? Correct or not, dear students? And from here, what we get? From here, we get x is greater than equal to 2. No? Correct or not? So now let's combine all these solutions. We have a value x is greater than equal to 2, and again we are saying we have a value of x which is greater than equal to 12. And that means obviously it is greater than equal to 12. We need to combine these two, na? Correct, na, dear students?
Yes.
If we combine this solution and this solution, what we are going to get? We are going to get x is greater than equal to 12. That is an acceptable solution. Or in set theoric notation, we can say x belongs to closed interval 12 to infinite. One thing I can say you, dear students, apparently it looks like complex, and relatively it is complex with respect to the other topics what we have discussed in linear inequalities. But for JEE main and advanced, you need to definitely do complex stuff. But what I tried my level best is to apply a proper process so that you can, make the solutions without having much confusion. So first and foremost, before I conclude the session for today, what I can say, dear students, is that first and foremost is very important to follow these guidelines for solving irrational inequalities. Correct, no? That these are the 4 guidelines as you see here. All of you are able to view it, no, dear students?
Yes.
Okay, great. These are the 4 guidelines has to be followed. When 2nth root of fx is less than gx, when the second case is that when the 2n plus 1th root of fx is less than gx, third one is that 2nth root of fx is greater than gx, and fourth one is that 2n plus 1th root of fx is greater than gx. If you follow these guidelines and little bit of practice, things will be absolutely perfect based on my experience, what I can say. So what I can do, dear students, now, I can give you a couple of questions that you can, do it and send me your solution. Do you think this is fair enough? That if you solve a couple of questions and do send me? And also, so tomorrow what we will do, tomorrow we will be discussing solution to the 3 questions what I gave for the wavy leveraging that wavy curve method, and these 2 solutions, these 2 questions what I'm giving using the irrational inequalities. Correct, not, dear students? Just apply your concept. Apply the concept what we have learned today. That is the first one, and this is the second one. Correct. So with this, sorry, I gave the same question. Sorry. This is the next question I'm going to give. Again, the same guideline. Whatever is there inside the square root has to be greater than equal to 0. And then you proceed. Okay, dear students. So with this, I would like to conclude the class for today. And tomorrow, I just repeat what we'll do tomorrow. Tomorrow, we will solve the 3 questions of that leveraging the wavy curve method, right? And solution to these 2 questions that we'll do tomorrow. And meanwhile, as you know, that you need to solve 2 more DPPs from the online platform at KonarClasses.com. Just I would like to just share, stop sharing this particular one and going to share another our KonarClasses website. Just confirm that you are able to view this website, KonarClasses.com. Could you please confirm that you are able to view it?
Yes, sir.
Okay, great. So here we log in. And what we get, dear students, is that you go to write online exam. And here, linear inequalities. We have done till 5th, no? Question, till 5 I gave, no?
Yes.
So,
I think 6.
I'm sorry?
I think 6.
Correct. Till 6. So, 7th and 8th you can complete. 7 and 8. And it will take another couple of days to complete the entire linear inequalities. Okay. And because we need to solve, we need to discuss about inequalities related to modulus, logarithmic inequalities, and exponential inequalities. These are the things we'll discuss. And I repeat, dear students, these are these are the topics which are important for very important for for JEE Main and Advanced. So next class we'll discuss about modulus inequalities. Then we'll discuss about logarithmic inequalities. Okay, and, and then finally we will discuss about exponential inequalities, and that will make our learning complete. Okay, so understood. So 7 you will go and view paper details, then write test, and you start getting questions and start solving it. You need to upload the answer paper and all these things. Correct. Thank you very much, dear students. I look forward to have a class with you tomorrow at 9 a.m.
Yes.
Thank you.
Thank you.